So what's an acceptable return value here from hash code?
Say 0.
I could return 0, right? So if two objects equal each other, and even if they don't, they're going to have the same hash code, right? Could I do something fancier with x and y? So suppose I have a point that's 1, 2, another point that's 1, 2. Could I do something with x and y mathematically that might give me the same answer if x and y are the same?
Maybe the sum of x and y.
Right, the sum of x and y. Or their product, or 3 times x plus y. Anything like that works, because then if the points do agree about x and y, their hash codes are the same. Now for equals, here's the mistake that many of us would make. So we take in a point for equals, and then we end up writing code, for example, if this dot x is not equal to other dot x, or this dot y is not other dot y, then I might return false, because they disagree about their x or y coordinate, and otherwise I could return true. And I misspelled that. Let me fix that. Okay, so logically this seems like a reasonable definition for equals, but if I run it, it had no effect on this set. Okay. So what's wrong, I would say, we would say it's the signature of this method equals. So what does the signature of a method normally include?
So it has the return type, which is the Boolean in this case. The name of the method is equals, and it's taking it a point.
Exactly. So the signature includes the return type, the name of the method, but also the types of all the parameters. So an equals it takes in a point is a different method, really, to Java, as different as if the name were different. For an equals it takes in, say, a color or some other kind of object. The signature we need to be successful here is actually the signature of object. So I'm going to replace this by object O. And in doing so, I still need to make a point out of that. I need my point other. I'm going to get point other from object O, but I do so, what's the technique I do to change O into a point?
You cast it?
Exactly, I would cast it to be a point. Okay, now once I do this and run the code, our set properly just has 1, 2 in it. I could add another point to it, say 2, 2. And if so, the set should have 2 points in it, and that works just fine. Now, this defining of hash code in equals is so tricky and frankly so tedious that Eclipse provides us a way to do that automatically. So what I'd like to do is comment that out and demonstrate how Eclipse can do this for us. And what I like about this is that it's based not so much on the code you write, but by what do you consider to be relevant to the equality of two objects. So for our point object, I can generate hash code in equals, and it says, well, what do you care about? Do you care about the x coordinate, the y coordinate? Do you care about both? In this case, we care about both, right? So we'll select both, and the code that's generated here has a fancy version of hash code, which works just fine. We'll see that in a second. But equals more properly takes in the right signature, namely that of an object. In looking at the code that's generated here, equals is checking, first of all, for the reflexive property. Are the objects exactly the same? Is the other object null? Are the objects of different type? But if we survive all those tests, we come down to the code that I wrote essentially earlier, where we cast the incoming object to be a point, and then we compare the x and y values appropriately. So this is an easier and usually more correct way of generating hash code in equals for these objects.